Hi, my name is John Delligatti, and thank you for attending my session at the ISA conference in Colorado Springs, Progress Over Perfection, Harnessing Existing Data in the Age of IoT. I'm John Delligatti, steering digital supply chain transformation at SDI. I'm passionate about leveraging technology to redefine supply chain management, and today I'd like to share some insights from the exciting evolution in data that we're witnessing. I mentioned the data evolution on the last slide. So at SDI, we have a term data is king. And in general, folks in the audience will realize that the more data you have, the better empowered you are to make smarter decisions. So regardless of the role that you're in today, ability to work with data is becoming the expectation, regardless of your previous training. So as more data pours in, we've seen the growth and promise of IoT, the sensor monitoring that's going to predict and pre-order parts for us in production lines. And this is happening in the most high end and capitally backed facilities. But the reality is that even though it's a $263 billion market forecast by 2027, that not all of us are going to have access to this technology, and not all of us will certainly have it communicating properly across all plants, all facilities, right? Right. We're still talking about the major players involved in this market for the most part. So that brings us to the challenges. Balancing this technology with your legacy systems can be a challenge. Security, and you need to bridge that skills gap that I mentioned with having people who are subject matter experts in their field, but also understand data. One of the key challenges we find, and it's prevalent in my role, where I'm always trying to digitally transform and improve business processes. We find that we're always chasing perfection, and a lot of the time we let perfect get in the way of good, really good, better than we're doing today. When you approach a project, under the guise of digital transformation, process improvement, and automation, you need to realize what the baseline is, what you'll achieve, and understand that not everything will be 100%, but that doesn't mean it should stop you, right? So I mentioned these struggles to integrate IoT, right? When people go out and buy these flashy new platforms, then they realize, oh, I can't perfectly tie this to this to this. And all of a sudden, if you've ever seen the Gartner hype cycle, you're going down into the pit of despair because this technology isn't what you were promised, right? So that's a struggle. And again, sometimes it goes with that theme of letting perfect get in the way of good. We can use what we have today to mine a lot of insight. And if we don't have it today, we can implement processes that will give it to us tomorrow. And that's this point, third graphic there about undervaluing our existing data. We have or have the right to obtain our work order data, our transactional purchase data, if we can tie asset information to those transactions. If we have an asset master that can be referenced, we can all of a sudden take a control tower approach where we can see across our entire ecosystem what's going on, what's being repaired more frequently, what's being repaired at this location more than this location, what piece inside of an asset keeps failing. How can we tell that without a sensor? We've bought it 5 times in the last year, and you're supposed to buy it once every 5 years, just as an example, right? So we can take what we have today and we can connect the data and the assets. We want to focus on that intelligent gap and really drill in on the asset management at your facility. Tagging. So in a lot of instances, assets are tagged, but work orders aren't always assigned the asset tag. In other instances, assets aren't tagged, right? We've seen operations at all ends of that, scale. Regardless of what you have today, tagging assets on the floor and then bringing them in to your transactional data provides you these tremendous insights, which I call a little tongue in cheek, but IoT light, right? It's not going to give you the predictive sensor based alerts, but you know what? If a unit continuously fails based on a work order being repeatedly put in for the same fix or the same part being ordered over and over again, applying the right intelligence to that can give you insights that are much better than we'd have today. So again, IoT is the future, but it's expensive, it's hard, it's not the only solution to get you to a better place than where you are today. We can use transactional and predictive analytics without the use of IoT, and we can leverage our existing systems to optimize our operations. So I'm going to take that story and make it real for you. We have a sample data set today, and I'm going to do the thing that's always scary and do an analytics demo live. So looks like it's loading today, so it's like My gamble is paying off. So what you can see here is a subset of data. This data is anonymized. It's not client specific. All of the prices have been altered. So none of this, is truly real, even if someone were to get in the back and pull the data out. But it's representative. And it shows you some of what we do to enable this asset tracking technology. So I know this is a bit of an eye chart. What you see at the top here is spend, purchase order lines, manufacturer names, part numbers, all tied to assets. Again, these assets don't have these fancy sensors on them, but we know what we're buying to fix them. We can see here that there's some manufacturers listed, and this is in particular, it's for a group of facilities, retail facilities. So a lot of these examples in particular are more focused on carts and refrigeration units and HVAC units, but we see the same with industrial use cases, and we do a lot of this with industrial clients. So when we take a look at this data, we can see here that there are asset keys, meaning an asset manufacturer part number, and we also have asset manufacturer at a high level. So we can see the most popular asset manufacturers in our list here are Amigo, Tenant, Hill Phoenix, Cassie. I'm going to go with Hill Phoenix here because Hill Phoenix is a manufacturer that we see across both the retail and industrial environment. If I click Hill Phoenix, this is going to change all of the analytics you see here to only reflect Hill Phoenix asset repairs. So what you can see here now is there are a bunch of different Hill Phoenix assets being repaired. You can see some are being repaired more than others. There's a very long tail, very small head, so it's very focused on a few assets that keep needing to be repaired. And you can see here that based on these locations, some assets have to be repaired significantly more than others, right? And there's a long tail there. So if we take a look here and pick the most used asset, and this has a good part number, Hill Phoenix ZH5, it looks like, are the last three. If we click this, now we can see what facilities are spending to repair this particular asset from Hill Phoenix and understand what parts are being consumed to repair that asset. So if I take this chart and make it larger, these are the locations that have had to repair this asset. If you look, again, just like the previous chart, there is a large head and a small tail. So there's, say between 50 and 100 locations repairing this asset, but of those locations, 8 to 10 of them are doing significantly more repairs than others, right? And you can see that here. So if we roll that back and unselect those stores, what are we spending to fix, what are we buying to fix these assets? If you take a look, you can see that by manufacturer part number, the number one is the 718001300. I don't know exactly what that is, but this is tied to that procurement data, so it is traceable. We can go back, and there's another report where you could pull the whole item detail on this particular item. As we go down the list, we can see there's additional items. And again, if you look and see that we've spent $256,000 fixing this subset of asset. Just back in the napkin math here, 63, 51, 18, half of that spend is being comprised of these three assets, or I'm sorry, these three parts that need to be repaired in these assets or replaced. So what that tells us is we could have an expensive part that's failing. We could have repetitive failures in these parts that indicate an upstream issue. These are all things that, we would expect our technicians to take this information and then do further research, right? Again, the subject matter experts need to be comfortable with the data. I am the data expert who's comfortable with the subject matter expertise a little bit, right? So you can see how, if that were reversed, this would be even more powerful. The other thing that we can apply, you can use this to apply to the asset management lifecycle, is we can use this to identify OEM commercializable spares. And that's, one of the golden geese of our engineering teams. And how do we do that? Well, again, in the presentation earlier, I referenced using our own transactional data to benefit us. What we can do here is we can take a look at every manufacturer name, manufacturer part number that went into fixing this Hill Phoenix asset. And we can bump up this list of parts that's been used to repair the Hill Phoenix asset against the bill of materials that comes from Hill Phoenix. And what we can do is we can say, hey, this part and this part, I'm just picking them out because they have different formats. These are not on the bill of materials, but someone is consuming them to fix the asset. So as an example, you might be buying a bearing from an OEM for $5,000, and you realize that it's actually an SKF bearing that you can source for $1,000 or $500 or what have you. There's tremendous savings to be had if you can see a layer deeper. And when you transact linked to an asset, linked to your entire organization, what it does is it democratizes the knowledge of that engineer who knows that. There's one engineer who knows that this part can replace that bearing, and maybe he tells his friends, or maybe he tells the people, or she tells the people at her plant. But how does that knowledge get truly democratized across the organization as people come and go? You embed it in the data and then use it to make better decisions. So this would grant you better visibility, better understanding of what's going on with your parts, and significant savings opportunities along the way. All right, I got through an analytics demo on a live call without it crashing. That's pretty good. So as we move on, the tangible impact of what I just talked about. You'll see a boost of efficiency and a reduction in downtimes. You'll see streamlined inventory based on predictions that are informed with your own data. And you'll see enhanced lifecycle management for assets, extending their life or replacing them before they become too expensive to maintain. Real-time data alert. This can be used in the context of real-time data monitoring and alerting if you take it a step further, right? So a lot of times we associate this real-time data monitoring and alerting with the IoT. Well, if we are comfortable enough with this transactional analytics, if we understand, hey, just as an example, I'm supposed to spend $10,000 a month fixing this asset at this location. We can set an alert that says, if I spend $10,001 fixing an asset at that location, alarm bells will go off and alert procurement, alert maintenance, whoever should know. And this isn't to say that this is an approval process that would stop you from, performing work. To be fair, if organizations want to implement that, they could. But the reality is this will help inform us of what's going on without disrupting the operation so that we can keep the plant up and running as best we can, while informing the folks at the strategic level who can understand it, ingest this at a holistic level, and make decisions to improve that asset lifecycle. So I know we walked through a lot there. We took a journey and we did it with data, which again, that's where I'm coming at this from. I am a data geek, and in the asset lifecycle MRO world, there is so much juice that we can squeeze out of the data we have available. So really just an advocate for using the data that you have available and understanding it, evangelizing that understanding throughout your teams. We can use this to be proactive in a world that's generally reactive, especially if we don't have the budget for all these IoT sensors. I'd love, for any kind of feedback on this and to collaborate on this professionally. As I said, this IoT light thing, I joke about it, but it really has legs. And when we show it to people in the industry, they're pretty impressed. So, love to, workshop with you and hear some feedback after the session. And, I would just love to embrace, again, using available resources, optimizing your process, and just put it out there that, if you're fighting the fires every day, it's obvious that it can be very difficult to, see the forest for the trees, if you will. But using data is a great way to take a step back and see an unbiased view of what's going on. To the point that I made on understanding data, my job at SDI, Director of Digital Supply Chain Transformation, it's my job to make sure people understand this data. So we recently put out a white paper called the Zeus Analytics Supply Chain Guidebook. And it essentially boils down the operational supply chain metrics that should be important to asset-intensive organizations, why they matter, why you should care, and explains them in plain English so you don't have to be a data geek to feel like you truly understand what's being tracked here. So I'd like to thank everyone for attending. I'd like to thank, ISA for allowing me to do this session and having me here. It's been a great partnership. Want to extend these links from ISA out to the group, and would love to open it for any additional questions or feedback. Thank you so much for your time, and look forward to collaborating with you.